I wanted to sort of talk about the purpose of this session. It is, intentionally supposed to be an informative session talking about transport, how the transport network integrates with your WAN and our network and other ISPs, and sort of, get a top view of those things. But the other thing I wanted to do in the purpose that I created this session was, having come from K-12 and having OSHEAN as my internet service provider, having Cox as my transport provider, it was always, there was a lot of terms, there's a lot of things that OSHEAN said that I just didn't understand. And it's through no thing of me just not, knowing the terminology. It was actually, I didn't live in the ISP world. I didn't live in that world. And then when I came to OSHEAN, I started understanding a little more what OSHEAN was about. So I wanted to start off the presentation, and I'm going to actually have Dave Marble do a little talking at the beginning, because one of the things I wanted to talk about before we get into the nitty-gritty of the network itself is who OSHAN is. What is OSHAN's purpose, and what it means to be a member of OSHAN. I kind of want to I'm going to have Dave talk a little bit about that. I might kind of weave in and out as during the rest of the presentation as well, but I'm going to hand it over to Dave and have him talk a little bit about OSHAN, who we are, and what we do, and our purpose, and your membership and all that.
Thanks, Brian. I appreciate everybody being on today, and anybody who's listened to me introduce OSHAN, for the first time to a potential member or new member, will hear me say that OSHAN is weird. It's a little bit strange being a nonprofit, and a nonprofit that has such a fairly amazing, sophisticated network underneath it. But it's good to understand the idea of being a nonprofit. Mark and I, came to OSHAN from the commercial world after being, in the commercial world for 30 plus years, and immediately you see what is the real difference. The difference has to do with our motivations, and I didn't quite know it all obviously when I was hired here 8 years ago, but I can give you a perspective of someone who goes to the board of directors, and I've been doing this for a number of years in other companies, and not having the KPI or the key performance indicators pointing directly at revenue growth. It's a different thing to have it be about the members and what it means to be a member. I am supposed to, from a board perspective and otherwise, be doing what you tell me to do, what you as members tell me to do. And sometimes it's very difficult to separate, this idea of this company that provides a service, and the membership requirements, if you will, to determine its path. And when OSHAN works best is when the members get together and say, here's a compelling thing that is really, working on our, staffs and really bugging our staffs and causing problems. Could we do something together as a membership and get it done? And that's when OSHAN works the best. And so I know, in a number of cases, Brian will go into some detail, we'll do a reach out and build, small working groups to try to work on a particular subject to get further on. The uniqueness of OSHAN's service offering, and I had this discussion with Brian. I know most of our members think of us as the ISP because what we do is we go after the internet bid from RIDE, but we're quite honestly far from an ISP. And we have ISPs as part of our service offering. We connect to ISPs, but we are doing far more than what a straight internet service provider does, or what a straight commercial carrier does, in trying to integrate and extend and do the kinds of things that are necessary for the community that give them the best bang, for their buck, and alleviates what I believe, especially in K-12, is a lot of strain on an IT staff. The quite amazing thing that's happened in Rhode Island, and you all know, that the Department of Education does not have a CTO. They don't have an organization at RIDE that helps you advance your technologies at your individual schools. They don't have a unifying thing. And the unifying body in this state for the membership of the schools is OSHEAN. We're the ones who are trying to get together and doing things like integrating the web filtering architectures, doing direct peering with Google, doing a lot of those things at the membership level. Believe me, it's a lot harder to do all of that on behalf of all of you than just provide you an internet service. And Brian's going to get into some of those details as we go along. Brian, what we're bringing to the table are a number of partnerships. We actually operate at RIDE the DMARC router, that runs all of the aggregation of all the schools in the state. We run that system. We are part of a national community called the Quilt. We are a research and education nonprofit in Rhode Island, but we are, as Doug likes to say, we're not a unicorn. There's one in Connecticut. There's one in New York. There's some huge ones in places like Michigan and North Carolina and California. And we are a community that talks and trades best practices and does that kind of stuff. We are connected globally to Internet 2, which is, just as an FYI, is now upgrading their core network to 400 gigabit transport and 100 gigabit packet optical, much like OSHEAN is upgrading its packet optical network to 100 gigabit. It's an amazing infrastructure and second to none. There's no question about it. And doing things like having Mirren, which is a New England and New York topology of private fiber that gets us diversity of where we get to our ISPs, like Boston and New York, and gives us access to further reaches like the East One cloud hubs, in Ashburn, Virginia. Those are all now on net to us, and we're able to provide a level of service on those links that again is second to none. And you guys know that we have a very sophisticated NOC. Global NOC is works out of the University of Indiana and works on behalf of a number of research and education networks, and is the NOC for Internet 2. If you were to peel back the onion and we were to just do this presentation about the tools and the databases and the knowledge that exist within the service department and what we know about your networks, it's unparalleled. So we put all of this in place, but it's on behalf of you. And so, we try to be an extension of your staff, and that puts a lot more responsibility on our folks. We're spending a lot of time from let's say an engineering or a diagnostic perspective, working on things that most providers would never get to, but we do it on the basis of being an extension of what you're trying to do and what you're trying to diagnose. And so I've always liked this little gear slide, because our IP service not only does content distribution networks that connect to the major titles like Google, especially in the K-12 space, or Akamai, which does content distribution of major titles, We do also, as you know, the firewall and the filtering, aspects. We host all that, in our network and connect those together. And we do a denial of service architecture or a perimeter protection mechanism. And what ends up happening is, and I don't want to use, maybe I will use the term taken for granted, is that those are very closely intertwined and very complex to build and support. And if we weren't doing that all as part of our IT service, they'd have to be individually managed and built and architected and diagnosed and so forth in the back end. And because we've put it all together and made it our IP service, it's supported under E-rate. So when we look at this stuff, and last year, I think it was last year, we had well over 300 volumetric attacks against our membership, many in the K-12 space. And what our K-12s get, or what our members get when they are attacked, is an email from us saying that we've mitigated that attack on your behalf. And we did, in building our denial of service architecture, we automated it. We built a very sophisticated analytics network to recognize the attacks, and we married that at an engineering or a software level in an automation factor with a scrubbing center that returns clean traffic. A lot of denial of service architectures black hole your traffic, so you're still down. So these are our state of the art and well recognized as being some of the best implementations of denial of service in the country. That being said, if you look at your packets going through there, it's not from one wheel to the next. We have not only visibility but lots of tools to do the kinds of diagnostics that are necessary. The one thing that has happened in the last 3 or 4 years, and really in the last couple of years has gone crazy, is individual application routing. So what used to be us sending a lot of traffic to a bulk internet service provider to go out to the commodity internet is now very different. We route major traffic to the major destinations that peer directly with those titles. And that gives you much lower latency, a much more stable use of that individual application, and better diagnostics on our side to try to figure out, what might go wrong. What that also does, though, and you should understand this, is that puts a little more onus on us, to be beholden to the performance of an individual application. We never were in that boat before. We take it on as an important part of why we're different. But you should understand that we're trying to do this now at an individual application diagnostics, maintenance, and support level, and that is very, very challenging in today's world. But we try to go on both ends, from the technical end and the service itself, all the way to helping you out with all of your E-rate, problems, and the E-rate, forms, and the, Melanie here knows what the bare forms and the audits that you might run up against with the PIA and all of that. We are in your court and very knowledgeable of what it takes to help work you through the issues that might come up, with your E-rate environments. I almost put that one up as much as the technical side of what we do in trying to help our members. Go ahead, Brian.
Yeah, thank you, Dave. So, to summarize what Dave was saying, as a member, I've heard Dave talk many times and was very impressed by all of these things. But I also didn't understand the fabric behind them, right? So OSHEAN's doing all these things. OSHEAN's creating all these things, the DDoS, helping with E-rate, considering themselves an extension of your districts. And all of the things that are put into place by OSHEAN are not there for OSHEAN, right? They're there for the members. people talk about, everyone's a sum of their parts, but our parts are literally our membership. It's not the network. It's not the switches and all the things that are, make the network work. It's actually our membership that makes up who OSHEAN is. I like to, akin it to other membership organizations where when you join something, you're part of it, right? You're part of the whole, and you have a say in what happens there. And that's really the core of what I believe I was missing as an OSHEAN member, and I didn't quite understand. And I know the people on this call, a lot of you are, people who get it. So I'm sort of speaking to the choir here. But I'm also speaking to, if anyone was to view this later, the recorded session later, just to let them know, it's a very different understanding that I had as OSHEAN being a vendor and OSHEAN being a community member, somebody who's part of my community and who I could actually go to and ask questions about, whatever those questions might be, whether it actually is relevant to OSHAN's design or not. The OSHAN's there to either provide an answer or provide a resource that can point me in the right direction. So, that's to sum it up. And I believe OSHAN is more than just another vendor, and it took me working here to really get that. And I just wanted to let people know, that's what we're here for. So I'm going to get a little deeper now into the technology discussion here. The next slide shows OSHEAN Speak. One of the things I always had a hard time with was the terminology that OSHAN uses. Things like Point Judith and Castle Hill, Beacon 2, even things like direct pairing, BGP and OSPF. Some of those concepts, local districts don't hear. They don't need to. They don't need to know what a BGP pairing is. They don't need to know what OSPF protocols are. They don't need to know why direct pairing exists and what good it is, so I kind of want to, as I go through and I talk to members, I try to untangle some of these OSHANese stuff. For the point of this conversation, though, one of the things to keep in mind, Point Judith, Castle Hill, those are just POPs that basically exist in our data centers. One Summer is a data center outside of it. So we have AP1, we have AP2. All of these things are just basically saying those are OSHAN's network. And those are nodes on OSHAN's network. Beacon 2, when people throw that out there, that's our fiber infrastructure. That's really all that is. And it's nice to throw that word out there because, it kind of gives it a name. But ultimately, that's the fiber that runs through our network and builds our network. Private direct pairing. I know a lot of you on the call understand what this means, but as we go through the slides, I'll describe a little bit more of how that matters to you, to us, and to you. And then, upstream providers, GTT, Harkin Electric, the difference between, as Dave was saying, the difference between who a raw internet provider is and OSHAN as more of a, management service provider or managed service provider. So here we have the OSHAN network. This is our fiber infrastructure. This isn't quite up to date. I pulled this from an earlier KVM. It's missing some of the Block Island stuff and a few other laterals and things that have been put in. But this kind of gives you an overview of what our fiber network looks like in the state of Rhode Island. It traverses almost every town, through every area. And you can see, as you get towards the more rural areas, we have less fiber out there. And that's why it's sometimes difficult for us to provide the amount of connectivity that we'd like to, when, in those areas. So we might go in and out of a school, but we can't go in and out of every building in that district. It's just the way originally when the Beacon network was built, there was a finite amount of resources, and the decision was made that we couldn't do everything, even though we wanted to. But as we grow, as we build, one of our goals is to make sure that you're getting the necessary bandwidth that you can possibly have, whether that's through us or through another provider. the funniest thing is when I joined Ocean, the biggest thing I didn't understand was Ocean's not here to sell you something. Ocean's here to help you with something. And that means that if you're going to get a better resource, a better solution through somebody else, we're not going to stop you, especially if that's going to help you in some way, shape, or form, and we can't provide it to you in that way. We're not going to stop you. We're not going to try to, sell you on something that you don't need or want. We just want to help. Obviously we need to make money. We need to be in business. We have employees. So ultimately, yes, we do want you to purchase our products, but it's actually on us to give you what you need. And for you to tell us what you need so we can, increase our services and provide better solutions. So again, this is just the overall network infrastructure, fiber network of Ocean. I'll get a little bit into what that means in a couple slides from now. But the next slide, I want to show you just the extension of our network. Dave was talking about the NERA network and some of our, partnerships that we have with other networks. This allows us to get up to the one summer data center up in Boston, get over to Albany, and get down to New York, to the Manhattan area. So this fiber infrastructure has allowed us to create diverse routes and increase the Ocean's resiliency, when providing connections to upstream providers. And then the other thing it does is allowed us to get the data centers that might have content delivery networks that are, in that data center that we can directly pair with. So by building out this network, and this is something that Ocean's done over many, many years, as we grow and grow and grow, we're not growing as like we're going to become, this big organization. We're still community focused, but we understand that in order to provide better service, or the best service we can, we have to diversify, and we have to be able to get into these areas and provide you with things like direct pairings. So one of the main topics that we wanted to discuss here was transport and internet and the difference between the two. I think most of the people on this call probably understand the difference between the two, but I know it was something that was very confusing for me when I first got here, when I was in the district. And I know there are some districts that struggle with this, so hopefully that they can benefit from these slides. I apologize if they're a little below level of some of the people on the call, but this is a basic overview of what a transport network is and how it compares differently to an internet provider. So in this slide, you're basically seeing on the bottom your district WAN, and the reason why it kind of overlaps in your transport network. In this particular one, this is the majority of our districts exist like this, who have multiple buildings, where you have a transport network that connects your WAN. It connects the buildings within your district. And that transport network may or may not be the same transport network that gets you to whatever ISP you're using. But it's basically your WAN infrastructure. They call it the VPLS network. That could also be your private fiber network. So you can create a private fiber, and then you're in charge of the internal transport network between sites. And then once it gets onto that transport network, it goes up to the ISP, or in our case, as Dave pointed out, we're more of an MSP than an ISP, but basically the person who's going to get you to the internet, the organization that's going to get you to the internet. Now, Ocean, has built other things within that ISP bubble, and we'll talk about that in a couple slides, but I just wanted to give an overview of how the transport network relates to and is different from your internet. One of the things.
The other thing, Brian, is in this state, and from a RIDE perspective, RIDE has two separate buys, as you all know. One is the transport network that Brian just described, and that's a separate buy, and they actually use a little bit separate procedure for allocating transport, as you know. all of the transport traffic in Rhode Island terminates at 235 Promenade Street in Providence on a router that is managed by OSHEAN. So whether it's coming from Cox, whether it's coming from your private fiber installation, whether it's coming from Crown Castle, or whether it's coming from OSHAN Transport, it all aggregates in Providence into what is essentially the ride aggregation or DMARC before it hits whichever internet service you go through.
Yeah, excellent point. You know, one of there are many reasons to, you know, that the state wanted to separate out these networks, but one of which is if you were to bundle the transport network with your internet network, with your internet ISP, and you could only give, you know, you can only get internet from the person who is also integrated into your buildings, OSHAN wouldn't be able to provide you internet. You know, we don't have fiber, we don't have connectivity into all of the districts and all of the buildings in the state. So although we can provide very, very good, resilient, redundant internet services with a lot of different on-net services, we wouldn't be able to do that for any district if they couldn't get to us. So the transport network allows those districts to get to us. Now it also allows them to get to Cox. It also allows them to get to, you know, whatever, you know, an ISP could spin up tomorrow in the state of Rhode Island and they could be a player. All they need to do is, like Dave said, is have that termination router happen, the aggregate router happen in AP1 on Promenade Street. And then they would be able to provide internet service from that location through whatever transport service that ride through the RITEEF program is getting them to.
Right. It's designed to provide more competition in both categories.
Correct. So on the next slide, you know, it's a little more robust. I know it's a little small, the writing's a little small, but I wanted to get a little bit more into our most cases, right? So you're a district, you have your transport network that's being provided, your internal transport network that's being provided by, let's say, Cox Communications. So you have circuits, and these circuits all connect to the transport network. And that middle network there, you know, this network here, that is the Cox transport network. That actually, once it gets there, they route it any way they need to, depending on where your traffic needs to go. If your traffic needs to go from one building to another, then it will go into the transport network and then down into the other building. And it will do that for all of the traffic that stays local. That might be printer, you know, building to building printer traffic, DNS, DHCP, anything that happens internally. It actually never leaves that transport network. And depending on the program, I mean, as long as your routing is set up that way, but the way it's supposed to be designed, the way that RIDE prefers it to be designed is just that. So the traffic wouldn't actually leave this transport network at all. It would only leave if that network is destined for somewhere else. So, you know, let's take a look at what happens to that traffic. So the traffic originates in this building here. It comes up into the transport network, and this traffic is, let's say, it's Google traffic. So once it gets into the transport network decides, hey, I'm going to now forward this traffic to where it needs to go. It's not internal traffic, so I'm going to forward it up to the next hop up here. And the next hop is the route, you know, the transport network router in AP1 on Promenade, which is connected to our router. So this is the OSHEAN network here. Once it gets on our network, and I'm not going to get into the weeds of how the traffic actually flows through the network, but once it gets there, it goes through your firewall. It'll go through the iBoss content filter, and I put iBoss in here because you know, and I want to talk about that in a little bit, but it will flow through to iBoss and then come back and then go to wherever it needs to go. All of these different things, One Summer, Internet 2, Akamai, all of these things that exist on the OSHEAN network. So you actually never go, if you're going to any one of these locations, you actually never go to an upstream provider. You never have to go out to the commodity internet. One of the things that is you know, beneficial to that is, you know, let's take like this DKIX. You might hear us talk about DKIX a lot. DKIX is an internet exchange. It's not really commodity internet. It's where content providers aggregate and terminate their networks to, and then we connect to that as well. So in essence, you're only a hop away from that content provider. Let's say a company like Apple is pairing with DKIX. When I say pairing, they have a direct connection to this DKIX data center. We also pair with the DKIX data center. So when you need to get to Apple, it might take that route. It might go through DKIX, and it might go then directly to Apple and never have to go over what we call the commodity internet. And let me go to the next slide, because there's actually a few slides here that'll describe this a little bit better.
One of the reasons we're talking about this is that the commodity internet in today's application environment is suffering, from the kind of content that the applications now have multimedia, larger data sets. Using the commodity internet is a variable result in things like latency. Sometimes it's not about bandwidth, it's about latency. How many hops are you going through? And if you're not building a network like this, you will suffer at the hands of commodity internet. It's a challenge that we struggle with, because a lot of times the only let's call it criteria that people look at is how much bandwidth am I getting for how many dollars? And they don't realize the level of sophistication and the actual things that are going on in the network that may have a grand effect on your application. And so we wanted to point out, how this stuff all works.
Right. And, one of the things that we try to do is understand what those applications are being used by our members. And, how can we provide a better path, a better redundant, resilient, whatever you want to call it, efficient path to that content provider, whether it be Google, Apple, YouTube, whoever you're trying to get to. So when we make our decisions about who we pair with, it's not just to pair with whoever we can necessarily, because we want to pair with people, with organizations that matter to our members. So in a private WAN scenario, and this is, down here at the bottom, you'll see the district WAN, and notice it doesn't kind of integrate with the transport network. That's more of a dark fiber, what we call dark fiber, or basically a private WAN. The district is responsible for its connectivity between buildings. It might be point-to-point wireless. It might be fiber that they ran through MuniSpace, or maybe it's dark fiber that they're leasing from somebody. But overall, the traffic within that network, within that WAN, stays within that WAN, and the responsibility is within that WAN. It's not actually going out to a transport network. There are many advantages to that. But one of the things that people might see as a disadvantage is, if you'll see, compared to the last slide where all sites go directly into the transport network, if one site, or maybe if only one site is going into the transport network, then that is a single point of failure. Now, the benefit there is you can have a larger pipe. The pipe is probably going to be, well, it needs to be larger because you're taking all the traffic from all the district and bringing it through one pipe. But you can make that pipe a little bit larger. And then there are other things that, can be done to make it a little more resilient, a little more, so to speak, redundant. But you still have to go through a transport network. So this transport network here could be OSHEAN, it could be Cox, it could be anybody. Basically, you have a handoff in one of your buildings, and that takes you to a network that will get you to us. If it's the Cox network, it'll go through many different routers, many different switches along their network to get over to Promenade and then connect to us. Same thing with us. If it's on our network, it's going to go through many nodes as it traverses our network. and then it'll get to us. And then again, once you're in our network, you have all the benefits of being on net and all of the services that we provide on net. Now, one of the things, and this slide isn't exactly as good as I wanted it to be, but I didn't have too much time to create the picture here, but I kind of wanted to take the map of Rhode Island, of our fiber, and explain a little bit of the ring topology that OSHEAN uses within its transport network specifically. So when you get onto the OSHEAN network from your site, let's say you have a direct lateral to our network from one of your sites. You are now on a ring, and that ring has built-in redundancy because there are multi-paths to get back to either data center. So either the one on AP1 or the other one AP2, both of them in Providence. So if a link dies somewhere throughout, and a lot of districts don't understand, when we zigzag in and out of buildings, that's our network. The node that sits in your building is the traffic of all of our network flowing through, or not all of it, but whatever's on that particular piece of the network. So you could have going through that box, could be other members, could be other things happening that gets them all the way through to our data center. If that node goes down, there's another path. There's this in the ring topology. It allows that traffic to go the other way around the ring through other nodes that get you to that location. And then there are
those are 50 millisecond automatic reroutes. And in with Robin on the on the call, one of those routes goes north off the island. You're in Newport or Middletown, right? Goes north off the island, and then the other route goes essentially west through Jamestown. And so you have that kind of ring resiliency off the island that gives you that 50 millisecond reroute of a failure that might impede your path to to Providence, right? So that's an example.
Yes, and one of the things the reason why I wanted to talk about the OSHEAN transport network, and I know that districts don't really have a choice of their transport provider because most are being provided through a RIT funding. However, if you're, we talk about resiliency, redundancy on the transport network. We don't control the Cox network, and the Cox network has a single point, where it aggregates into in our data center in Promenade. The reason why that's important is because if AP1, if something happens to that data center, and you have a Cox transport getting you there, then we have no way to get your traffic to our other data center because we're not controlling that traffic. That traffic doesn't go through our network to get to us. So if it gets to that data center and then can't go anywhere, you basically are going to be black holed. And things happen, right? I mean, we all know that data centers, I know that OSHEAN had that little bit of issue many years ago with the fire alarm that happened to AP1. And one of the things OSHEAN did was to diversify the resources after that. So, we took our firewall services and we brought them and separated them. So one actually exists as a redundant box up in Boston, and the other one exists over in AP1. In the event AP1 were to go down and you could get to our other node in Providence, AP2, you could then be routed up to Summer Street in Boston and still get all the services you would normally get. One of the reasons why OSHEAN chose to go with iBoss Cloud and start going in that direction, and the cloud service for that was the same resiliency that you would get where you don't have a single point of failure existing in one of our data centers, and you would be able to route that traffic up. If you happen to be on the OSHEAN network, you're in luck because you will be routed whichever way gets the traffic to where it needs to go with redundant data centers in play. With Cox, could you get to us another way? If you could probably purchase something that could get to us, but again, you're on the Cox network and they only have that one aggregation point. And again, it's tough because a lot of districts don't have the ability to talk about or to choose the transport provider. But this is one of those times when I talk about benefits of something like dark fiber, right? We always talk about dark fiber. We always talk about you linking your network together. Well, why does that matter? It matters in situations like this. It matters where if you can create a dark fiber network and you have control over that, then you can have dual path out of your network onto the OSHEAN network if OSHEAN is your transport provider. And there's many cases where we will try our hardest. If we can provide transport to you, we will do what we can to do it. Not because we want the business, although we do, but more so because we think that our transport network is better than other transport networks, that we can provide you with a better service and have better uptime and resiliency on your network through our transport network. So that kind of covers, what transport is, how it works, how the OSHAN's transport network works. And then I kind of want to get into a little bit of a traffic flow thing. And we sort of went over this on the last slide, but, I kind of want to sum it up here. So you have an end user that's sitting in one of your buildings and they go through your building's LAN infrastructure, getting up to what they call the edge router. The edge router then transfers onto the transport network. Basically, the edge router is part of the transport network. Once it's on the transport network, it gets to the OSHAN data center or data centers, depending on which one you're going to. Once you're on there, there are lots of things in the OSHAN data center that exist where you don't have to leave. You could put in our Navisite, tenancy up there, you can spin up servers that would be on our network. It would basically look like another building on your network because it doesn't have to go anywhere. It's literally just sitting off a router on our network. And this is where private pairings come in. I kind of briefed over it a little bit earlier, but I wanted to talk a little bit more in depth here. When we privately pair with somebody, we can either do a direct pairing where we have an agreement with that content provider and we connect through them through protocols that are used. And that might be Google, that might be Apple, that might be anything like that. We might have something on our network, maybe maybe the Netflix caching server, right? So we have a caching servers that sit on our network that, again, that traffic doesn't leave our network. So with a device like that, when this end user brings up a Netflix movie, that movie actually never gets, you never have to get to the commodity internet to get to that movie. It actually stays on our network. And all the benefits of that with all of the large connections that we have to these different services that are on net. And, Dave was talking a little bit about the DDoS mitigation. And one of the things I wanted to talk to is what Dave was sort of saying. With DDoS, it's very easy for somebody to say, oh, we provide DDoS. It's a cloud-based DDoS. It might be a DDoS. You're going to be protected, but you're going to lose all connectivity. You're going to be black holed, is what he said. And ours is unique in that we won't do that. We actually get the traffic scrubbed, and we'll pass on the clean traffic to the end user, all automatically, all without them knowing. So that DDoS service was chosen not because it's the easiest one to do, because it's far from the easiest DDoS to do, but it was chosen because OSHAN felt that it was best for our membership to give them the resiliency that their network needed, rather than just say, yeah, we're providing DDoS and yep, you're good, you won't get attacked, but you might lose connectivity for a while it's happening. We didn't want to see that. Our members' connectivity is important to us, and we wanted to make sure that we put something into place and built it into our network and not pass that cost on. We're not charging our members for DDoS. We want to make sure that it's just part of doing business here at OSHAN. And then, one of the other things I wanted to talk about on this slide was our upstream providers. The CDNs, the content providers, the anonymous system network, number networks. And those are, when you get to these upstream providers, as Dave was saying, routes can change. You know, we have no control over routes once it hits that commodity. AT&T can decide, you know, you're going through an AT&T circuit. They can decide, yep, we're going to drop this route for whatever reason. And now your traffic's completely routing somewhere across the world, across the country. There's just no way to control that traffic. It could go over, you know, a dozen hops before it gets to its final destination. As an end user, you may never notice, or you might. When Verizon had that outage, you know, a few weeks ago, it was noticeable by a lot of people because a lot of organizations, a lot of content providers were using Verizon internet services to connect to eventually connect the end user. In a scenario with direct, you know, with a private pairing, and you're not going over commodity, those type of outages, those types of redirects, those types of routing will not affect the traffic flow. And as an additional benefit with the direct pairing is that we can directly pair with somebody. And if for some reason that direct pairing has an issue, you can still get to that provider over commodity. So there actually is a built-in level of redundancy when you build those types of networks. So why does OSHEAN do this? Again, it's not easy. And we have a lot of very, very intelligent people behind the scenes making it all happen. We could just say, yep, we're an internet provider. We get you to commodity. That's all it takes. But you're not going to get the level of resiliency. You're not going to get the level of efficiency in a network without us doing that. And again, we don't do it because, you know, it's going to help us. You know, that's not why we do it. We do it because we want to help our members. And I think that's the most important thing. And again, to bring it back around, is that I want to really drive home the fact that this is all your network. I call it the OSHEAN network, but it's not. It's the members network. Everything in this bubble, everything in, you know, this thing up here, hold on, is you. That's your network. And we're just an extension of your local LAN. We're just an extension of your end user. And
I mentioned earlier about you know, key performance indicators and the way we try to drive our business. One of the metrics that we try to drive is how many times do we tell you that you have a problem before you notice it. We're actually at a ratio of about 20-1 that we're telling the member that they have an issue because of all of the diagnostics and individual application level sort of looks. Because a lot of times what would happen normally is you may have Google down, but the internet's not down. And in a standard ISP environment, that might not be, you know, the right way to go about it, right? It may be a problem deep inside Google, of which you may not know happened, you know, pretty significantly a few weeks back. And that was a Google specific issue that we were able to diagnose, understand, reroute around, and get back up at an application level, as opposed to bulk internet level. So you know, those are the kinds of, you know, on the ground, the realities of what today's network really looks like.
Yes, exactly. You know, so along those lines, you know, we keep saying we want to be an extension of you guys. You know, we want you to ask us anything. If we can help, we might not have the answer, and we might not be able to help. We might be able to say, you know, that's not really in our wheelhouse. We can't really do that for you. But you'd be surprised at how many things we might say, hey, wait a minute, that's a good idea. Maybe we should incorporate that into our network. Maybe we should create a private pairing. Maybe we should create a service. We want you to drive us. We want you as a member to come to us and say, you know, here are my challenges. Is there anything you have that can help me? And if not, maybe we can build it. And it might not be right away, but I think it's important to have these discussions. And along those lines, you know, we want to start incorporating, you know, member engagement a little more as we go forward. We want you involved. You know, one of the great things that I've been involved with over the last year is the tech director's call that happens weekly. actually happening in a few minutes. And that call is great because it's open conversation. It's just people talking about the problems they're having. And I love being in that call. I'm not there because I want to sell anything. I want to hear those problems because if we can provide a solution, and sometimes we can do it better, only because we have the ability to buy in bulk. We created discounts with Cisco Umbrella because our membership is so big that we might be able to get something that you guys need or could want at a significantly discounted rate, or something that we might just be able to provide you, like our member portal where you can see your bandwidth. We're talking about doing, a VAR and being able to do security scans on your network and build that sort of thing to help you as a member, with the things that you might find challenging because you're stuck in your day-to-day. I need to fix these computers. I need to just I need to help these end users, and you're not thinking of those larger picture things. We want to help you think about those and help you solve those problems. I'd like to incorporate, regular member meetings, and what I mean by that is where we have a meeting similar to the tech director's call, where we bring everybody in and we just talk to them about what their trials and tribulations are, what they're seeing that's great, what they're seeing that's not, what somebody else might be doing better. We're not going to sit here and think that we're the best thing out there, because we know we're not. We know there's always room for improvement, and we're always in contact with our other network providers, this Connecticut one, the REN, the California, all of the RENs out there that we can. We try to keep in contact with them to see what they're doing that might help our membership. And
one
then
of the things that is very challenging for us is to try to figure out the right way to have a piece of your time to have that discussion. We've tried all sorts of things. It was different pre-COVID than it is now, in trying to figure out the right way to communicate with you all, because this is obviously an evolving field. We're doing a lot of things in security. We had a call yesterday with the municipalities about email security that I thought was fascinating, about what you can do for free in email security. 3 really quick and, sort of down and dirty, led by, Doug Alexander and Kim Kanoyer from our staff. We don't sell any, it's free. We don't sell it. It's a technique. It's a thing. It's something that everybody can do. And it really does move the ball along in your security practice. And so, but I don't know collectively at the K-12 level that we have a really great pulse on what you are struggling with today. Like, what do you want to do next? And so we look to you to try to help us understand how to do that. What would work for you?
And along those lines, we want to create more member engagement opportunities. We want to do the regular member meetings, create sessions around that, and whatever that might mean to you guys. We actually don't want to lead them. We don't want to be like, we're doing this and here's the agenda. We want it driven by our membership. We want our members to come in and say, here's what we're looking to do. Here's what we want. And then, maybe some ideas for some knowledge sessions, like this one about transport. I just decided to do this one because it was always confusing to me in Bristol Warren. I didn't quite understand it. And I fielded a lot of these questions, especially with, tech directors or network managers who come on, who have never lived in this world before, informational sessions that will allow us to explain even more in depth, whether it be one-on-one or in group form, whatever works for you guys. We're here to answer your questions, to help you. Give us a call, email us, whatever is needed. I love to talk. I love to tell people everything I know, every information I've ever learned. I just want to give that away because, I struggled with a lot of things in my past of learning a lot of things. And once I learn something, I love to show people what it is and how I learned it and what it means. So along those lines, we only have about 2 more minutes. Are there any questions that anybody has along the presentation, or anything you want to add to it? Feel free, raise your hand, speak out, there's not many people here, so. All right. I think we're good.
Brian, I was thinking as you were talking about analogies to use for a lot of these different network configurations, and one thing that occurred to me is that some of our private, peering and off the public internet services are kind of like the series of tunnels they have underneath Toronto, right? Where it's like when it's serious wintertime, you don't have to go outside, you don't have to brave the elements. You can go underground, and it's this sort of little private protected area that gets you from place to place. I kind of like that.
Yeah. And we like to create more tunnels if it's going to benefit our membership. If there's a benefit to creating a tunnel to an SIS, one of the SISs, then let's look into that. And whether we can or not, who knows? Depends on how their infrastructure is set up. But if we can, and that'll help, then absolutely we'll do that. If you're struggling with connectivity to one of your resources, an SIS, a testing site, anything like that, we want to hear about it, because maybe we have a solution for you.
Well, we didn't talk a huge amount about the portal, but if you as you start to use more cloud services, you may have a couple of particular applications that just become that front end critical thing, and we may want to know about that so that we can partition that route out. If it happens to be you've moved something to Azure or something like that, so that we can always have very quick diagnostics on that particular application. So we need to have that dialogue so that we can have that, presented for you.
All right. Well, I'm done here. Nemoto.
Thank you, everyone, for joining us this morning. Again, this session is being recorded, so I'll be sure to share this, and you can also visit our YouTube page to check out all the other fun stuff OSHEAN has been up to. Hope everyone has a great rest of their day and have a great weekend.
Thank you very much.
Bye-bye.
Thanks, everyone.
Thanks, guys.
Thank you.